All right, so today what we're going to work on is multiplying radical expressions. This is the backside of the 7-2B note paper, or sorry, 7-2A note paper. All I have here on the very far left is just a complete example worked through here, and right above that is just a definition. You can multiply together like radicals, meaning if you have both of them are square roots or both of them are cube roots, they can be multiplied together. You cannot multiply a square root and a cube root together, or a cube root and a fourth root together, but as long as they're the same type of root, you can multiply them together. And what you want to do is find the product of what's in the radicand, which is what's underneath your radical symbol. So just a quick example here. Third root. What you do here, 54 times 5, 270. And you're going to use your exponent properties here with the variables. When you multiply like bases, you're going to add exponents. So m squared times m to the third is m to the fifth. The rest of the process is what we worked on, where we broke down the radical, whether it was a cube root, fourth root, or square root. And as you get down, any perfect cubes in this case you can take out, you want to remove, and anything else gets left under the square root. So we're just going to move on and get into these problems right here. So if you do have numbers outside the radical, you're going to go ahead and multiply those together. So outside the radical, 3 and 2 multiplies together to give me 6. Under the radicals, what I'm going to do, I'm going to grab my calculator here real quick so you guys can see what I'm doing on the screen, hopefully, and not put it over the problem. All right, so I'm going to go ahead and take 7 times 21. It's going to end up giving us 147. And in terms of the variables, x to the third times x to the squared, you're multiplying the numbers, you add those exponents, that would become x to the sixth. There's no other y in the problem, so that's going to stay y squared. We're working with a square root here, so I want to divide 147 by any of the possible perfect squares. So I'll just show you real quick right here. The biggest perfect square that goes into 147 is 49. I'm going to pull this to the side. So I'm going to rewrite 49 times 3. Now I'm working with the square root, so we're going to keep, we don't need to break apart either one of these radicals because they're both exponents that are divisible by the root, which for this question is 2. This is a square root. Okay, square root of 49 is 7. Square root of x to the 6th, we're going to divide the exponent by the root. That'll pull out as an x to the third. Same thing here, divide the exponent by the root. So this will just be plain y. Now, anything you pull out in front, you're going to multiply together. Since there was a 6 already here, I'm going to go ahead and multiply 6 times 7. So 42, and then x cubed y, and then still stuck under the square root here is the 3. Same process, except for this is a cube root. So what I'm going to do here is we're going to go ahead and squish these together. I'm going to do 25 times 5. So if I do that, 625. And I'm going to add the exponents on the like variables. So x times x to the fourth is x to the fifth. Y to the ninth times y to the third is y to the 12th. Okay, now we're doing a cube root, so you want to think of your perfect cubes. The biggest perfect cube that's going to divide into 625 is 125. So 625 divided by 125 is 5. Now, I need for a cube root my exponents to be divisible by 3. So this is x to the fifth. I'm going to rewrite x to the third times x squared. And the y to the 12th, we're going to keep it because 12 is already divisible by 3. Remove any perfect cubes. This is going to be 5. X and y to the fourth. Divide the exponent by the root. All that's going to come out in front, 5xy to the fourth. And then try not to forget this. This is a cube root, so put the little 3, the index here. Left underneath, you had a 5 and then an x squared. Pause this at any time if I'm going a little bit too fast. Okay, go ahead, and if we're multiplying like I don't want to, sorry, let me rephrase that. If we're multiplying radicals that are the same, if they're both a square root, both a cube root, you can do that. Just squish them together. Square root of 5 times square root of 10, square root of 50. The biggest perfect square that's going to divide into 50 is 25. And the square root of 25 is 5. 2 stuck under the square root. This question, just think about this as having a 1 in front of it. I'm going to go ahead and multiply the numbers outside the radical together. 1 times negative 4 is negative 4. 5 times 20, that's actually 100. Now, this is a perfect square, so I have a negative 4 out in front, and I'm going to multiply that by 10. So I actually don't even have a radical left in the answer here. It's just negative 40. These are both cube roots. The cube root, go ahead and squish them together. Negative 3 times 9 is negative 27. This is a perfect cube. The cube root of negative 27 is negative 3. And then just a couple more down here at the bottom. All right. 1 times 4 is 4. That's going to stay out in front. If you do 18 times 3, you're going to get 54. And a squared times a squared, add the exponents a to the 4th. This is a square root. The biggest perfect square that goes into 54 is 9. And I'm going to keep this a to the 4th. It's already a situation where you're divisible by the root, which is a square root. This is going to come out as a 3. This is going to come out as an a squared. Now, I already have a 4 in front of the radical here, so anything we pull out, we're just multiplying everything together. 4 times 3 is 12. Put the a squared with that, and then you have this 6 that's still stuck under the square root. Negative 4 here times, this would just be 1. We're going to keep a negative 4 out in front. And these are both square roots. We can squish them together. 28 times 7 is 196. X times x to the 3rd would become x to the 4th. So I'm multiplying together to create a single radical. And then 196, I'm not 100% on that, so I'm just going to check. So 196, let me check 4. Okay, now if 4 goes in, and this is actually 49. All right, those are both perfect squares. Let me check something real quick. If those are both perfect squares, then the actual number should be a perfect square, and it is. So 196 is actually a perfect square. So the square root there is 14. And so no radical the number. This is divisible by 2. And so this is going to end up being a perfect square here. Now, to get the answer, anything we pull out in front, we're going to multiply. So I had a negative 4 already out here. Negative 4 times 14 is negative 56. We have the x squared, and then nothing was left under the radical for that question. Now, one more. These are both cube roots. So I'm going to go ahead and squish them together into a single cube root. 2 times 4 is 8. This would be x to the 1st, x squared, so that would become x to the 3rd. We're adding the exponents. Y squared times y to the 7th. We're going to add the exponents. We're going to get 9. Okay, now as I'm looking at this, 8 is actually a perfect cube. 2 to the 3rd power is equal to 8. So if I do the cube root, then I'm going to end up with 2. This exponent's divisible by 3. This would pull out as an x. This exponent, also divisible by 3, this would pull out as y to the 3rd. So completely getting rid of the radical in that question after you multiply.